Hello boys and girls. The relativity of motion. Let's break this sentence into two parts. Relativity, and then movement. That is, first let's talk to you about relativity. Mom. A student came from school and said I got a B in math. So what? Says Mom. And the boy answers. Well, how can I tell you, so what? Regarding Val, I got a very good grade, because Val was getting a deuce. But regarding Nadia, I got a slightly worse rating. What does a little bit worse mean? I got 5 for that. That is, you and I always use the word relative in relation to some other body. That is, there are always two bodies. When we talk about some kind of relativity. For example, I am taller than Petya, but I am much lower relative to Vovka, because Vovka has grown by 2 meters. Well, about relativity, we did something, so to speak, skumakali, right? Well, let's talk to you now about the movement. Movement, what is it? Here I stand like an idol, I'm moving somewhere. What do you think? Well, someone might say, you have something moving there. No, we're not talking about that. Basically, here I am standing right here, yes, that's how I get up. Not moving anywhere, that's right. I'm not moving anywhere. That's right. But someone may say, we live on Earth. And the Earth rotates, correctly, around its axis, and moreover, also around the Sun. That is, I am in motion with the Earth, that is, if someone now looks at me through some super telescope, he will say, he is moving and within 24 hours he will make such a circle. If someone looks, well, as if from another star or galaxy, yes, he will see that the Earth is moving around the Sun. I mean, I'm moving with her, right? But we will not enter into these subtleties, so to speak. All right? Here I am now standing still and not moving anywhere, that's all. But if I start walking now, you'll say aha, he's in motion. And why? That's because with respect to these letters, and now go to the side. Here I am getting closer to this letter C, now I'm getting closer. And now I can move away like this, but from the letter C, right? Here in this situation, yes of course. You are 100% sure that I am on the move. Now let's imagine such a situation. Here we were, as if on the shore of the ocean. Pacific Ocean. Well, for example, I specifically said the Pacific Ocean, it's not so quiet, but the Pacific Ocean. No breeze, no sun, no clouds. Peace and quiet, warmth. And you and I look into the distance and see that, as it were, the ocean merges with the horizon. Yes, there is such a line there far, far away. That's it. And suddenly, a lonely sail is turning white. That is, I saw something there, some point. Far, far away. And they said to me, well, you see, there's a ship there. Maria himself. I say, I see the ship. Well, where is this ship going? I look, I can't understand anything. Period. Far, far away. I can't tell if it's moving to the left, or if it's moving to the right, or if it's getting closer to us. I don't understand. And why? Because I can't find something, so that's something that's relative to what it will move. But if two ships appear on the horizon, I can determine something. Once. This means they are moving towards each other. That is, as soon as two bodies appear, something can be said about what, so to speak, relativity. Relatively, yes, then you and I can already determine something, so to speak. Well, let's look at this option with you. The option is like this, I wanted to draw it. So let's try this marker. FR, there's something here. Here is a straight line, we can clearly see it. And another straight line. And let's imagine that this is some kind of road. Alright, here is some piece of road and here is this car, Moskvich 405th. That's it, that's it. I have a question, and where is this car Moskvich 405th located? I see, right, that's it, that's it. Where? He may be in Ulyanovsk. What did I say? Alright, in short, it may be located somewhere in Sestroretsk, or it may be located somewhere in Novosibirsk. In short, what happens? To solve the main problem of mechanics, and you know what it is, that's physics in general, right? Here, related to the movement. With the help of formulas, methods, with the help of concepts, it is necessary to determine all the time where this or that body will be located. Why is it moving, and what can happen to this body? And so on and so forth. Why is it moving and so on? It doesn't matter. So far, we are becoming with you that our main task is to determine where this body will be at any given time. That's it. Well, I said, here it is. Well, is this some kind of very weighty information? No, of course not. I do not know where this street is and I do not know where this house is. Now look, I'm going to draw a house. Here it is, a house. Here's a pretty little house. Here it is. Yes, there is a window. We draw a pipe and the smoke goes. Warm, good, porch. That's enough. Yes. And I draw that this car is a Moskvich 405th, it is located right here. The specifics have appeared. That is, if we leave the house, you can say, here you will leave this house, turn left, walk, take a walk and find this very car. Well, yes, there are millions of such houses, right? Well, where is this house? I don't know, that is, there must be some specifics. If we say that this house is located in Novosibirsk, as I have already said. Yes. On Gagarin Street, number 8, here. I got the most useful information. That is, if I find this house, get out of it, turn left, walk, I'll find this very car. I see, right? Well, let's add more specifics. Here. If I say that this house on Gagarin Street is our reference point 0 point, then I can even count the number of meters. Yes, here it is 10, then 20, and here it will be 30 meters. That is, we leave the house, yes, turn left and what happens? We can find cars. But let's get back to the relativity of motion. So, this car that Uncle Vazia got into, after leaving the house, she drove. Question. Is it moving? And say yes. And you will be absolutely right. Do you know why it's moving? Because it starts to change its location relative to this very house. She's moving away from him. Of course, Uncle Vazia can go in this very direction, and in this direction he will approach him first, drive past him and start moving away in the opposite direction. This means that this movement is nothing but a change in the location of the body relative to other bodies. Here there may be a Christmas tree of some kind. Right? And here is some kind of lime tree. And here, do you understand? Oh, Uncle Vazia drove in the opposite direction, he drove past the lime trees. Oh, Uncle Vazia drove in this direction, he drove past the Christmas tree. He approaches her, moves away from the lime tree. If he comes here, he moves away from the Christmas tree, approaches the house, then approaches the clip, and so on and so forth. That is, if a case changes its location, it is in motion. But it's not that simple. Because his son Koka is sitting next to Uncle Vazia. Well, let's imagine. Uncle Vazia is here, Kolya is here, and they are going. Location changes. That is, Kolya is also going, here. Do you understand? Uncle Vazia. Regarding this, regarding this, regarding this. And then Albert Einstein looks down from heaven and says, well, guys, what do you say about each other in the car? Are you moving or not? Oops. Question. Uncle Vazia, how much will they move relative to each other? No, of course, they are relative to each other all the time in the same kind of place, on the seats. They don't move. And so yes, Albert Einstein says, well, let's conclude with you that any movement is relative. That is, before solving any problem in physics, we must decide about what or whom we will consider motion. Well, that's it. That's enough for now. All the best to you. Goodbye, see you again.